Today I'm going to show you how to build an air purifier for $30 that independent testing at the University of California, Davis showed delivers clean air delivery rates competitive with commercial purifiers selling for $300 or more. I have been running one in my bedroom for 18 months. I replaced a $400 dedicated unit with it, and I will never go back. Stick with me through the filter section, because there is one rating number that makes or breaks this entire build, and I am going to walk you through the full assembly, from the exact materials to the last strip of tape, before this is over. The device is called a Corsi-Rosenthal box. Richard Corsi is an air quality engineer and the Dean of Engineering at Portland State University. Jim Rosenthal is a professional filter manufacturer. They designed this together in 2020 when hospitals, schools, and community centers needed rapid air filtration and commercial supply chains were running months behind. The design was published openly. Several universities ran independent air quality tests. UC Davis estimated clean air delivery rates of 165 to 239 cubic feet per minute on a standard build. Many commercial HEPA purifiers priced at $300 deliver in that same range, and some fall below it. $30 in materials. The standard air purifier works like this: one fan, one filter panel. The fan pushes air against that single filter face and has to overcome whatever resistance the filter creates. The denser the filter, the higher the resistance, the harder the fan labors, the noisier the unit runs, and the less air it moves per minute. The clean air delivery rate is capped by that single bottleneck. The fan and the filter are fighting each other, and the filter almost always wins. The Corsi-Rosenthal box removes the fight. 4 filters arranged in a cube, fan mounted on top. Same fan. 4 times the filter surface area. The air now has 4 separate routes through the filtration instead of 1, which drops the resistance against the fan sharply. Lower resistance means the fan moves more total air volume per minute, at lower speed, more quietly. Each filter panel handles only a quarter of the total airflow burden instead of all of it. 4 panels running in parallel where a commercial unit runs one solo against the same motor. That difference in geometry is where the performance gap between a $30 build and a $300 machine opens up. Here's exactly what to buy. A 20-inch box fan, $20 to $25 at any hardware store or big box retailer. 4 20-inch MERV 13 furnace filters, $4 to $6 each. 1 roll of duct tape, $2. Total build cost, $28 to $34. No special tools, no cuts, nothing custom. Everything comes off a standard shelf in one trip. The fan must be 20 inches, not 18, not 24. 20-inch furnace filters are the most widely stocked residential filter size in North America. They line up flush at the corners when you build the cube, and the fan face covers the top opening without gaps. A different fan size requires hunting for matching filter dimensions, risks ill-fitting joints that leak unfiltered air, and adds complexity the whole point of this build avoids. 20-inch fan, 20-inch filters, both decided before you leave the house. For the filter brand, Filtrete, Nordic Pure, and Honeywell all work. Any MERV 13 from a major brand at a hardware store is fine. If your store labels filters in MPR instead of MERV, MPR 1500 is the MERV 13 equivalent. FPR 9 is the closest match in the FPR system. Check the package before you buy. The brand matters far less than the rating. Now the rating itself. This is the part that ends most builds before they start. MERV 13, that is the number. MERV stands for Minimum Efficiency Reporting Value, a scale that runs from 1 to 16. Higher means finer filtration. MERV 13 captures particles down to 1 micron in size. Smoke, pollen, mold spores, fine dust, pet dander, and a meaningful percentage of the 0.3 to 1 micron particles that do the most cumulative respiratory damage over time. Below MERV 13 and you are moving air without stopping the particles that matter. Above MERV 13, specifically MERV 16, the highest residential rating, the filter media is so dense that a standard box fan cannot push sufficient air volume through it. The resistance overwhelms the motor. Technically excellent filtration, almost no airflow. The clean air delivery rate collapses. MERV 13 is the exact rating where filtration depth and fan airflow work together rather than against each other. The fan can drive air through it. The filter captures what needs capturing. That pairing is the entire engineering logic of this build. If someone at the hardware store suggests going up to MERV 16 because it sounds like a better product, on this fan, in this configuration, it is not. It kills the airflow. There's a fire hazard concern that comes up every time this build is shared, and it deserves a straight answer. In 2012, Underwriters Laboratories updated the box fan safety standard after motor fires were documented in older models. Every fan manufactured from 2012 onward with a UL listing includes a thermal fuse built into the motor housing. When the motor overheats, the fuse blows, the fan stops. Any fan you buy new today at a hardware store carries that standard. The fire hazard people warn about traces specifically to pre-2012 fans pulled from decade-old garage storage. Check your fan for a UL mark and a manufacture date. Post-2012 with a UL listing, the fuse is there. You are running this safely for as long as the fan motor lasts. The build. Lay the 4 filters flat and look at the cardboard edge of each one. Printed on that edge is an arrow indicating airflow direction, which way air is engineered to travel through the filter media. When you stand the cube up, all 4 arrows must point inward toward the center of the box, not outward, not mixed. All 4 pointing in. A single reversed filter forces air backward against the layered grain of the media, which drops that panel's filtration efficiency sharply and throws uneven loading across the remaining 3. Arrows in, all 4. Mark the arrows with a pen before you start assembling if it helps. Stand the filters on their edges in a square, each one butting up against the next at the corners. Open cube. Open at the top and open at the bottom. The fan goes on top, blades facing downward, pushing air into the cube. Air enters through the top via the fan, gets pushed through all 4 filter faces simultaneously, and exits clean on all 4 sides of the box. Seal every corner seam where 2 filters meet with 2 strips of duct tape running vertically. Seal the bottom perimeter where the filter frames rest against the floor. Seal the connection between the fan housing and the top edge of the cube. Any unsealed gap is an air bypass. Unfiltered air taking the easy path instead of going through the filter face. Tape every joint twice, turn it on, 5 minutes, start to finish. The ongoing cost comparison. Mid-range commercial HEPA purifiers charge $40 to $60 per replacement cartridge and need a new one every 6 to 12 months. For MERV, 13 furnace filters for this build run $16 to $24 total and last 3 to 6 months under normal conditions. Commercial unit, $300 up front, $60 per year in cartridges. This build, $30 up front, $20 per year. After year 1, the commercial unit has cost $360. This one has cost $50. Run it to 5 years. The commercial unit has cost $700. This build sits at $130. Same clean air delivery rate. One costs 5 times more to run. One more detail on room coverage. Standard residential purifiers list maximum effective room sizes of 200 to 250 square feet at their rated performance. The UC Davis tests measured effective coverage up to 400 square feet on the Corsi-Rosenthal build. 1 box covers a large bedroom and a hallway. 2 boxes cover an open plan floor for $60 total. $30, 5 minutes. I've been running mine for 18 months and I am not going back to cartridge replacements. Send this to someone still paying $60 a year to breathe filtered air. Like the video if it helped.